Hi everyone, welcome to the session, and today we are going to discuss about routing protocol. So in the last class we learned static routing, and when I introduced you routing protocols, we discussed about the two major categories which were static and dynamic. Now under dynamic there are again two categories: interior gateway protocol and exterior gateway protocol. Under interior gateway protocol we have RIP, we have EIGRP and OSPF. So when it comes to static routing, we learned that uh, just a minute. Yes. So when we were configuring static routing, there used to be like three routers, and let's say there's a network of 1.0 on the first router, and on router number two, we had 2.0. Then on router number three we had 3.0. So now what used to happen was we had to configure the remaining routes which are not directly connected to the router. So in case of router 1, we had to add 2.0 and 3.0 in its routing table. And when it comes to router number 2, I'm sorry, 2. Yeah, when it comes to router number 2, we had to we like add up 1.0 and 3.0 in its routing table. And similarly for 3, 1.0 and 2.0. Now, okay, now, when it comes to dynamic routing, and when it comes to dynamic routing, what we do here is so we are not going to add 2.0 in its routing table and 3.0 in R1's routing table. Instead, we will tell R2 that R1 is configured with a network of 1.0. We will tell R3 that let's say R1 tells R2 that I am managing the network 1.0. So in case if you receive any packet which is supposed to be for any device of my network, you can simply give it to me. Similarly, R2 will advertise about its network, which is 2.0, and R3 will advertise about 3.0. So that's how dynamic routing works. And we are going to learn about some characteristics of this routing protocol. We will learn how we can configure this on a topology using packet tracer. But before that, we have something to complete. And in the last class, we were discussing about VLSM. So let's quickly complete that and move to RIP. Yesterday we discussed about VLSM, and we were left with 16 networks. So out of the 256 networks, we configured 240 on these routers, which are admin, HR, marketing, and sales. Now we were like willing to connect these together, and to make this possible, we have to use the remaining 16 networks. So that's something we are going to learn about. So the ranges ended at 239, and the last range which we configured in sales ended at 192.168.1.239. So we still have IP ranging from 1.240 to 1.255. And in cases like these, where you just have to configure two devices, we use /30. And to calculate this, you can simply go to NH, the formula which we use. So now we have a requirement of two hosts. And may I know the nearest number we can use to configure a network of two hosts? Yes, correct. So we have to use 4. Why? Because there will be one network ID and there's going to be one network ID and one broadcast ID. Then after that, you can use the remaining two as hosts. So now NHSR will go something like this, and host will be 2 raised to the power 2. And when it comes to network part, we'll be taking 6 as its power, and subnet will look like something 255.255.255. And if we turn on the first 6 bits of the master formula, which we have 128, 64, 32, 16, 8, 4, 2, and 1. If we turn up all these 6 bits, 128, 64, 32, 16, 8, and 4, we will get 252. So subnet mask will look like something like this. Then after that, we have range. So the range will begin from 192.168.1.240 and will end up at 243. So this is going to be the first network. And after that, the next network will look like 192.168.1.244. And after this, we have now, if we take a look at the topology which we have for VLSM. So now we need at least 4 networks, one for this, one for this, these two, HR and marketing, and one for sales and marketing, one for admin and sales. So we have the information ready with us. We just have to connect them, and simply we can configure the IP addresses. So we'll go to cables, take the automatically choose connection. We will connect them. And all you have to do now is configure the IP address from these ranges. So we can take the first range for connecting HR and admin. Then we can choose the second range for connecting admin, HR and marketing. Then the third one for marketing and sales, and the last one for sales and admin. So I hope you'll be able to complete this on your own, as yesterday we discussed majorly how it works, and now the IP configuration is only left, and that's not a big deal for you. It's been 8th or 9th day of this training. Let me know if you guys want me to configure this, or shall we proceed further? If you want, I can give you some time. Meanwhile, you guys can practice this if you are left with the completion of this topology. So let's take 10 minutes to quickly complete this. Anyone who is left with the completion of topology can configure the IP addresses on these networks. And after that, we will look into RIP. So you guys have 10 minutes. Let me know once you are done. So as most of you guys are done with the topology, let's move further and learn about RIP. So, okay. Is it clear now or shall I try resharing the screen? Great. We are going to learn about RIP, and RIP stands for Routing Information Protocol. We are going to discuss about some of the characteristics of RIP, and let's understand how RIP works. So first of all, RIP is a open standard protocol. So this means that you can configure RIP on any vendor produced devices. So it doesn't have to be Cisco device in order to configure RIP. You can configure it on other network devices as well. So the next thing which we have for RIP is it is classful and classless. So when we talk about RIP, we have two versions. The version 1, which is like almost obsolete. Then we have version 2. So the version 1 is classful, which means it doesn't support subnetting. And when it comes to version 2, which is like mostly used, it supports the subnetting. So if you are willing to do subnetting on a network, let's say which looks like something this, and if you want to do subnetting on the devices, which is configured with the RIP. So you have to make sure that you configure it with version 2. So first one was Open Standard Protocol. Then it is classful and classless. Then after this, we have the metric of RIP. It uses the metric of hop count. So now let's understand what is this metric and hop count. So metric is basically the cost of a route. So let's say there's a router R1 and we have another router R2. Then there's another route which is R3 and R4. Then there's the destination router R5. So in order to reach R5, if the network is connected over RIP, R1 will always choose R2. I mean this route in order to reach the destination router, which is R5. Why? Because when it comes to hop count, this route has less number of hop counts as compared to this route. So let's say this is route 1 and this is route 2. So RIP will always choose the route which has the less number of hop counts. So if we talk about R2, so R2 is the hop of R1. So the next router which we have on the topology is usually known as hop. And after this, we need to understand something, that RIP can only work with 15 hops. So we can say maximum 15 hops can be configured, or we can say can be connected using RIP. So 15 hops means total 16 routers, right? And we have something in chat. Yes, so as I told you before, this is also known as distance vector. So the name now would be like more. Uh, Now this will make more sense to you why it is known as distance vector. So it chooses the route which like where it has to travel, uh, where the distance from the source router to the destination router is less. Then the fifth thing which we have for RIP is AD, which stands for administrative distance. So AD value of RIP is 120. So now let's understand one more thing. Let's say these routers are connected over multiple protocols. So this is the router 1, this is the router 3, the destination router. So let's say now they are connected over multiple protocols. Let's say we have EIGRP, which we are going to discuss about in the coming classes, OSPF and RIP. So all of these three protocols are configured on this network. So the protocol with the with the minimum AD will be chosen by R1 in order to reach R3. So the lesser the AD, we can say the lesser the AD, the more the protocol is preferred. So is it clear to you guys? So protocol preference is more when the AD value is zero. Oh, I mean the less. AD is administrative distance. It's the value of protocols. Sure. Okay. So we have like multiple protocols when it comes to routing. We can see, we discussed about something called RIP. We discussed about EIGRP. We discussed about OSPF. So these are like routing protocols which we can use to make communication from different networks possible. Is it clear till now? We know the use of routing protocols, right? And after this, let's say you have a network. Let's say you have a network where you have these three routers, and R1 is the source and R3 is the destination. So let's assume that EIGRP and RIP are configured on these routers. So the AD value of EIGRP is 90 and RIP is, as we just learned about, is 120. So tell me which protocol will be preferred by R1 to reach R3? EIGRP, right? Why? Because it has less AD value as compared to RIP. So AD value is not something we deal with. It's like predefined, and it's just for our understanding that if a network is configured with more than one protocol, let's say OSPF, RIP, and EIGRP. Let's say this network is configured with all three, and when we talk about OSPF, the AD value is 110. So if all the three protocols are configured on this, so the protocol with minimum AD value, or we can say the least AD value, will be selected to make the communication over devices. Is it clear now? So AD value is used to make decision between protocols. So let's say now RIP was the one who won. Like RIP was chosen by the router to make the communication. Now once RIP is selected, after this, the in order to select the best route, hop count will be used. Make sense? Jaspal, are you like able to understand this? So once RIP is selected, then after that, the best route can be chosen using the hop count. So is it clear now? Great. So the metric for RIP is hop count, and AD value is used to select the protocol. So let's say the network is configured with multiple protocols. In that case, AD value will be used to select the protocol. Now this RIP sends periodic updates I will let you know, don't worry. As of now, you just keep in mind that 120 is for RIP. Once we talk about EIGRP, OSPF, we will like discuss about that. So RIP sends periodic update every 30 seconds. On if these devices are connected using RIP, they will share periodic updates. So they will update each other about their routes every 30 seconds. Then after this, we have timers of RIP. So we have, okay, I'm going to erase these characteristics. If you are like making notes, I would request you to take a screenshot. This is the multicast address on which devices listen for the periodic updates. So now we have one thing known as invalid time. Invalid time in RIP is 180 seconds. And if the router doesn't receive update, or let's say route updates for 180 seconds, it breaks the relationship. And won't share further updates. So now let's understand what is this. So let's say these two routers are connected over RIP, and in case, so as we discussed, they share periodic updates after every 30 seconds. So in case if one of the router doesn't share the update for 180 seconds, which is the invalid time, so after the completion of 180 seconds, the router will break relationship and won't share any further update with the router. Is it clear? Then after this, we have another timer. Now, after the completion of 180 seconds, we have a timer called flush time. So flush time in RIP is 240 seconds. So after invalid time, uh, which is like of 180 seconds, if the router doesn't receive update for another 240 seconds, then after the completion of 240 seconds, it will remove all the informations about that router from its routing table. So we have this router, then we have another router here, R2 and R1. So let's say R2 goes down and doesn't share the update for 30 seconds. Then the R1 will wait for 180 seconds, and after the completion of 180 seconds, R1 will break relationship. Break relationship means R1 will not share any update with R2 or won't share the traffic to R2. So after 180 seconds, R1 now again waits for 240 seconds, and in case if R2 still doesn't reply or still doesn't share any update, so after 240 seconds, what R1 will do from its routing table, it will remove all the routes which are like connected through R2. So let's say there were route to reach R3, R4 and R5. So what R1 will do, he will just remove all the routes which are going through R2 or any information related to R2. So these were the timers of RIP, and you guys can take a note of this. After that, we'll be moving to packet tracer to learn how this works. So these are the default timers, and yes, you can make changes into that. To make the process faster, you can make changes. So I hope you guys are done with noting down the characteristics. So let's now quickly move to our favorite part, which is practical, and learn how RIP works. What are the commands which are supposed to be configured on routers to make them connected over RIP. So just give me a minute and we'll learn about RIP after that. Okay. So now we are going to do a very simple practical, and we will try making communication between different networks. We have R1 here, and okay, we have two switch for them, and then after this we have two PCs. So this is our topology. We have two routers, and we are going to configure class A IP address for this since we haven't used it till now. So let's just take a IP from class C, and after that we will look into some complex topology, maybe with four routers, and we'll take class A IP in that. So we are going to configure 192.168.1.0 on router number router number 0. Then we'll configure 192.168 on this. And between them we can configure 192.168.3.0. Now we'll quickly go to R1, go to CLI, say no. So, okay. So now we will go to enable config T, which is configure terminal. And after that, you can change the host name to R1, FA00 first with the IP address 192.168.1.1 and the default subnet mask. Shut down, enter. Now we'll go to interface FA0/1. We'll type the IP address 192.168.3.1 default subnet mask and then no shutdown. So once we are done with the configuration of IP on router number 1, we can go to CLI of router number 2. Okay, conf t, change the name to R2. Then interface FA0/0, find the IP address 192.168.2.1. Shutdown. Then assign the IP address on FA01 192.168.3.2. It was done, and let's quickly configure DHCP as well. So let's take an exit. IP DHCP pool A network 192.168.1.0 and the default subnet mask. Similarly, on R2, we'll create another DHCP pool. Now let's assign IP address to the PCs. And here we go. Now, if you try to ping from PC number 22 to PC number 23, it will go successful. And similarly, if you try to ping these two PCs, it goes successful. But if you try to ping from PC 22 to PC number 24, it says it's failed. And even if you retry this, it's still failed. Why? Because we still have to configure the routing protocol. So in the previous classes, we discussed about static routing. And in that case, we used to add these networks, which are not there, which are not directly connected to the router in its routing table. However, as we discussed, now we will advertise about our networks. So we are going to tell this router that I have 1.0 and 3.0. Similarly, this router will tell that I have 3.0, I have 2.0. So now let's understand how this works. What are the commands which are required? So we will go to configuration mode and we will type router RIP. Then press enter and tell it that version 2 shall be used. After this, you have to type network and out the directly connected network. So we have directly connected to us as 1.0. And then we will type again network 192.168.3.0, right? Take an exit. Let's go to router number 2. And in case you are not sure what all directly connected routes are there on the router, you can simply go to show commands and type show IP route. Here you have the list of directly connected routes. So we have 2.0 and 3.0 on this router. So we will advertise about them only. We'll go to conf t. Okay, so we'll go to configuration mode. We will type router RIP 10 version 2. You have to type network 192.168.2.0 and again network 192.168.3.0. That's all. And you have successfully configured RIP on both of the routers. Now, if you go to router number 1 and take an exit from this, say show IP route. So now we have three routers. The first one we have is 1.0, then we have 2.0, then we have 3.0. So now this router is also aware about 3.0. However, we haven't like told router 1 that there is a network with 3.0. So that's something which is done by RIP. So if you see there's an R near to the network ID and that R can be called as RIP, like R refers to RIP. So this route is received from RIP. Similarly, if you go to router number 2, take an exit from the configuration mode, say show IP route, you will see 1.0 with a R. So this 120 is the AD value and the one you see, the one after the slash represents the number of hops. Yes, you use the command no auto summary when in that case. That's correct. So in case you are doing subnetting, you have to use another command with the configuration of RIP, that's no auto summary. And you can like in that case, we will use that command. So is it clear till now? Guys, like, do you guys understand how RIP is configured? Yes, it is. So we have difference. Okay, difference between version 1 and version 2 is that version 1 does not support subnetting. However, if you choose the version 2 supports subnetting. Yes, sure. So if you go to PC22 and try pinging the PC, ping 192.168.3.2, so you receive the reply, right? So that was something known as RIP. I'm giving you 10 to 15 minutes. Let me know once you are done with this topology, or if you want me to write the commands, I can do that for you. So the step 1 is IP address. Step 2, then step 3, RIP. So the configuration will be first you have to write router RIP. Then after that you can say version 2. After that you have to just advertise your directly connected route. So that's all. So if we talk about router number 1, so this is going to be the configuration, and talk about router number. Configuration will look like router RIP, then again version 2, then network. That's all. Praveen, I was on mute and you have this time to try this practical. So Rachel, if you want to configure any network, you need the router. So server has some different functions and router have some different functions. So yes, no issues. Please try to do this practical on your end on the packet tracer, and you have around 10 minutes for this. After that, we will try with 4 routers with a class A IP address. I hope most of you are done with the practical, and now we are good to move forward and understand the same with a different topology. Let's practice one more practical and we are good to go. So this was RIP. So we have a question that what is the router RIP command for? So this is to enable routing protocol RIP. So in order to enable the protocol, you have to type this. Okay, so now we will look at some different topology and we'll try to configure that with RIP. So let's take router. So we will quickly add up switches for them and here we go. We have one switch for all of the networks. Then we will add N devices. Let's take 2 PCs for each network. Now we are good to go. Okay, let me drag them down. So that's our topology for the practical and okay. Now we will quickly connect them with the cables. Here we go. Okay. Just a minute, guys. Okay, wait a minute. So does it mean we don't use static routing? Yes, Jaspal, it is usually avoided in like big organizations. And so we have a doubt here from Shubham that there's something related to sequencing, that what IP should we configure in case of our IP. So there's no such thing related to that as of my knowledge. But yes, when until and unless you like, if you have connected the routers over a serial link. So I avoid discussing such routes because we have some very new people to this. But yeah, so here we have a doubt that so Shubham is facing some difficulty in adding the route to routing table using RIP. So he's not sure what IP shall we configure in RIP at first. So the thing is that if you are using a serial link over the router to connect them together, so you have to like configure the IP on both of the ends, and until and unless both of the like links are up and running, the entry won't be there in the routing table. So if you are like missing on some entries, so make sure that both of the ends are up. So once the ends like this link is up and you have successfully configured the IP on both of them, so you'll be able to see the entry. That's also in the case of serial link. So I hope that makes sense to you and you are able to analyze the situation more specifically. Sure, make a try on that and we'll if you still face any issue, we can talk about it later. So we have this topology with us and we will try to configure this with class A IP addresses. So let's quickly rename them from router number 2 to some locations, or we can say simply to them. Then we have this as 2 and this 3, this one as 4. So we have these routers with us and okay. So I hope the interface name is visible now. So we will configure a network of, let's take 10.0.0.0. Then we have we'll go to the CLI of router number 1, say no, enable conf t. Okay, so we will quickly assign the IP address to internet 1/0 and the default subnet mask and no shutdown. So we are going to take 14.0.0.0 here, then similarly 15, and 17. We are going to configure interface FA00 with the IP address of 14.0.0.1 and default subnet mask. Then let's go to interface FA01 IP address 17.0.0.1. So here we are done with the IP configuration of router number 1. Let's move to router number 2. We will go to CLI, enable property. Once we are in the interface Ethernet 1/0, we will assign it the IP address 0.0.0.1, then default subnet mask and no shutdown. This we will go to interface FA0/0, assign it IP address 14.0.0.2. Now this interface FA0/1, then IP address 15.0.0.1. Down, and we will now move to router number 3. We'll say no, enable quantity interface Ethernet 1/0, IP address 12.0.0.1. is FA0/0. IP address dot we will take exit and quickly configure DHCP on them. So I'm creating DHCP pool on this. So this is my network. I have the default subnet mask. Router will be so we'll go to router number 1, quickly configure the DHCP. We have a network of 10.0.0. We'll give IP address to the PCs, and it works well. The DHCP is working. Now, great. So DHCP is working fine. Okay. After this, will be like advertising our routes to the routers using RIP. Once that is done, we'll be able to make these PCs in which are in different networks. They'll be able to communicate with each other. Okay, here we go. Now we are done with the configuration of IP address on PCs. Let's move to router number one. And since now we have multiple routes connected to us, we'll take exit, we'll write show IP route, and now you have this information with you. You can move to configuration mode, write a router RIP version 2, and after that you can one by one add the routes. So we have 10.0.0.0, then after that we have 14.0.0, and at last we have 17.0.0. That was all for the configuration of RIP on router number one. Now we will move to router number two, and okay. So here we have router number two with us. I think it's back now. Are you guys facing some issues with the video? Okay, just a minute, guys. Allow me a moment. Is it better now, or like are you guys able to see the screen? Okay, great, fine. So now we are on router number two, and we have to configure RIP on this. Now, if we take exit, write router RIP. So before that, I want you guys to understand something. Now, since you are in the configuration mode, and you want to like see the route, so you don't have to like every time go back to the privilege mode. What you can do here is you can add do show IP route. So all you have to do is you have to add do. Am I still not clear to you guys? So as most of the people are like able to hear me, so it seems like there is some issue at your end, or maybe you can try rejoining the session. So in case you are facing some issue, you can try rejoining the session, as most of us are able to like see the screen. So in order to run commands from privilege mode, when you are in configuration mode, you have to just add do before the command. And once you type and press enter, you will be able to see the routing table even when you are in your config mode. Then after that, now we have the list of directly connected routes with us. We will configure RIP net. Router RIP version 2, then network 11.